Disruptors and curious minds, the brave, the courageous, the special. Welcome to Thinking on Paper. And on February the 10th, 2009, an active American communications satellite slammed into a defunct Russian satellite at 22,300 miles per hour, 13 times faster than a rifle bullet. The resulting explosion blasted thousands of softball-sized bits of shrapnel and hundreds of thousands of smaller fragments into near-Earth orbits. For the non-Americans, softball size, I believe, is about the size of a tennis ball, maybe a bit bigger. As NASA scientist Donald Kessler cautioned decades ago, the worst case scenario is that this domino effect causes LEO to reach a tipping point beyond which collisions are ever increasing and unstoppable. The Kessler Syndrome. And it's not just theoretical. Thousands of satellites are crumbling above our heads. The orbits around which they orbit full of junk. Today, we're going to be addressing that problem. In Act 1 of the show, we'll be asking how we got here. Why should we be optimistic about clearing up space junk? Why we should be pessimistic? We'll be learning about Astroscale and flirting with them so that they come on the show. And we'll be talking about the politics of clearing up space junk. And then in Act 2, we'll be moving on to market power, space monopolies, decentralized versus centralized power. And we'll be looking at SpaceX's position and ask whether their domination is great for space innovation for the long term as much as it is for the short term. Stick with us. Jeremy, take us on a journey to space junk.
Buckle up, kids. Buckle up, kids. Off we go. So first of all, my question for you, Mark, is what are the strategic tactics to flirt with a company like Astroscale on a podcast? 3, 2, 1, go.
Well, I think that probably starts with speaking about Nobu Akada, the founder, visionary, business, human behind Astroscale and his motivations for creating that company. And we'll get to them very shortly.
Cool. Well, let's jump right in. So this our last review kind of left some lingering questions from the last few chapters. Number one, this idea of can NASA be this coordinator of trust, of goodwill, that sort of thing, ties it in. And one of the things that I circled here in the beginning of this chapter is, they talk about markets, they talk about competition, they talk about public and private, but kind of what also happens when the invisible hand of the market doesn't work, right? And how do we address those market failures? One question, quote, this is what I really like this one, quote, will we repeat the same mistakes made over the past several centuries of terrestrial economics? Because we are lifting and going to space. We always talk about, don't bring your old problems to new innovation land, right? But
are you talking about the tragedy of the commons and externalities, Jeremy?
Absolutely is where we're headed with this. Kessler. Should we go to Kessler first?
In 2023, the US Space Surveillance Network estimated that the total number of trackable objects in orbit, so that's debris larger than that softball we spoke of, had surpassed 23,000. But fragments ranging from 1 to 10 centimeters numbered more than 500,000. And as for the tiny shards of metal smaller than 1 centimeter, estimates put that volume at 100 million particles or more. We need to get a proper scientist who can tell us how important is it for those 100 million to be removed. Can those do damage to satellites? I assume they can if they're moving at 23,000 miles an hour. If you get a handful of centimeter long shards of metal or whatever they're made out of, that's going to do some serious damage to your solar panels.
100%. But also, we'll get to this later. J.C. Liu, I think, was the researcher that referenced the biggest way to affect change in the overcrowded orbit scenarios, grab the big stuff first. But I think the small stuff is actually just as big of an issue because it's moving so fast. It's like bullets.
As we know about life, don't we? It's the small things that count. Talk to us about Donald Kessler, Jeremy, and the Kessler syndrome.
Donald Kessler wrote a paper in 1978, and it talked about the density of objects in space and that collisions will actually accumulate faster than, or the potential collisions will accumulate faster than the atmospheric drag can remove them. So collision potential is increasing quicker than stuff gets pushed into the atmosphere and burns up by itself. There's a certain point where the problem becomes it's too far down the road. Pandora's box, so to speak, is uncorked, and we can't pull back even if we don't launch anything else. Just from a high level perspective, it's been I've read it a few different places. Roughly 70,000 objects kind of put us in that realm. But think about this. This week, Elon Musk put in for a license for 1 million objects.
A
1
million?
million objects. So anyway, suffice it to say, it comes back to coordination and trust, the human things that tend to mess innovation up in certain ways. So,
Well, how did we get here then?
how did we get here?
How did we end up worried about the space junk? Why is there so much space junk? And why are Astroscale and other governments and the space industry at large so worried about it? How do we get here?
SpaceX has figured out how to bring down launch costs by over 90%, right? So now we're like, oh man, we can shoot things up there. And then companies like some of the satellite companies we've been talking to are putting together, or not we've been talking to, that are referenced in the book. Who are the doves? Remind me of the doves?
Planet.
So Planet figures out how to make satellites out of shit on the shelf at Radio Shack. So they're able to shoot these things up and make some tests and do some things. So the barrier to entry is not removed, but significantly reduced. So it's like, oh man, let's see what we can do with all of this. So you got China's putting up a bunch. You got Starlink is putting up a bunch. You have Amazon, who has a couple of prototypes up, but they're down the road gonna start putting some things up there. And I think one of the biggest things we talk about in the book and space economy in general is that the space to Earth economy is the first unlock for space economics in general. I think, like, how you can monetize what you can capture from space to Earth, and that requires satellites, that requires orbits, that requires all of these things in coordination.
Yeah, and the human weak spot. So the tragedy of the commons, quote, an economic and environmental science problem where individuals have access to a shared resource and act in their own interest at the expense of other individuals. This can result in overconsumption, underinvestment, and depletion of resources. As far as space debris, it's a classic externality, a side effect. So satellites, anti-satellite missile tests in orbit.
This was really
space stations. There's a lot of people just doing stuff up in orbit, putting things up there, blowing things up there, with no regard for the future generations and other people and other companies and other nations who wish to go up there. It's pretty much like, okay, space is my backyard. I'll do what the hell I like. Be damned with all of you. And here we are.
Let's talk about anti-satellite missile tests.
Yes, please.
I looked into this a little bit. I guess in China in 2007, they had a satellite up there that they shot down, created 3,500-ish trackable objects. So back to your softball reference, 150,000 total fragments. And the stuff that's still up there allegedly won't decay for a century. Here's the problem. You can't track, you can't say, oh, these are China's 3,500 pieces and parts, so they need to clean up these things. They're just parts up there that are not ownable and trackable kind of thing. Hey, wait a minute. Here's an idea. Create something in the material of satellites that has a DNA on it. And the DNA is trackable to the bits. So maybe it's something that you weave into the satellites, and when they get destroyed, a little bit of that DNA is in each piece and part. Then you jump in, you have your satellite, you roll around, you scan them, and you can identify who left their crap in low Earth orbit. What do you think?
That sounds like you're just entering a big blame game, if you ask me. Maybe
That's really what it is.
Rather than maybe like decomposable satellites. I think that's what we need, decomposable satellites. So it's interesting what you said, because you said 100 years that anti-missile test might last. So this is interesting. How long will all this debris stay in orbit? It depends. So NASA estimates for orbits under 600 kilometers, where the atmosphere produces more drag, debris and dead satellites will burn up within a few years. At 800 kilometers, it could take centuries. And at 1,000 kilometers or higher, it could take thousands of years or longer. So it depends how high, in which orbit they are. And just for a bit of data for your satellite launches. So this book was released in 2024. So this will have changed. But at the time of writing, OneWeb 648 satellites, Amazon's Kuiper project 3,200, China's Guangwang 13,000, and SpaceX 42,000. And you just said that's now 1 million. So a lot of stuff's going to be going up there. So if you want to be pessimistic, then there you go. What's a conjunction?
So Hugh Lewis, now just friends and neighbors, not Huey Lewis of Huey Lewis in the News, but Hugh Lewis. He researched something called conjunctions, which is the chance of two objects passing really closely by, right? So let's look at some stats. Mark, you're a stat guy. Let me throw some at you. 2020, there were 1.7 million conjunctions observed or predicted. 2021, 2.5 million. 2022, 4 million. So we're getting up there. But here's the thing: these are not like near misses, but they're close enough to require diversion, close enough to require a little burst. And how many maneuvers does Starlink plan?
Each Starlink has 350, has enough fuel to do 350 of these deviations over a 5-year lifespan. So good luck with that. No wonder he needs 1 million of them.
That might not be enough. If you have 4 million over the satellites that were up there, like at the time, probably 40,000 divided by 4 million, that's a good amount per satellite. You're digging into that 350 maneuvers. Could get dangerous up there.
Do SpaceX give them more fuel? Do they keep them further apart? Like if every satellite, if it has a conjunction to it, what is it? Do you have a conjunction? Is this a verb?
No, that's conjugation.
It's a conjunction. Yeah.
Well, here's
busy up there.
Here's the interesting thing. As we're just thinking about it, like my entrepreneurial brain is kind of spinning around a little bit, that, man, there are going to be so many things for people to figure out and so many new potential business opportunities with the complication of doing what we want to do in outer space, in lower Earth orbit. There's going to be enough stuff for people to figure out to create a whole bunch of businesses. And it goes back to, do we have the patient money to make our wishes and dreams come true?
Well, talking of money, this is the final economic frontier. So they speak about the economics of space junk and the insurance and the risk, and it's not included in the current projections from the space market. The additional risk from on-orbit collisions is currently an insignificant amount of the total insurance. There's no incentive to pursue other options. In other words, the market doesn't care. It's not accounting for it. So if the market isn't accounting for it, if the market doesn't care about it, you can address the tragedy of the commons, the space commons, in two ways. Governments, and what's the second?
Well, there are a couple of interventions that governments can do, I think, that he goes into. But you said, like, the market doesn't care. What was your phrase there? You read the quote.
It's not incentivized to pursue as options.
So you know what I thought about? You know what I thought about immediately, and oddly enough, you mentioned it at the top of the show, is that a terrestrial comparison to this would be like plastic straws and plastic water bottles. Do we need to clean the ocean? Is it putting plastic bodies into our bodies? Absolutely believe that. But there's not enough incentive for any one player to go out and say, hey, let me clean up everybody's mess. And the people that are making the bottles like, no one's really bitching that much yet. Let's keep riding it. And that way we don't have to figure out how to address the cost of it. So I think it's applicable.
Yeah, well, that's the tragedy of the commons with plastic, and the oceans and the dolphins and the turtles and the porpoises all suffer their individual fate. So broadly speaking, the market isn't going to solve this problem. So the tragedy of the commons can be addressed in two other ways. First up, governments. We're back to the government question, Jeremy.
Oh, let's put. Hey, I got this idea, Mark. Let's create a moon treaty. Let's go around and get people to sign the moon treaty. We go around and we do that. The problem is the majority of the people that sign the moon treaty are not spacefaring. So it's kind of this.
And that was 1979, so yeah,
might have changed by then.
Spacefaring nations than then, but yeah, that didn't work. But then, as you know, it took until the 2000s for an awareness of space debris to become common. So governments, the United States created a set of guidelines in 2001 to mitigate the creation of new debris, including a requirement that all satellites in LEO, where most debris is concentrated, must be safely deorbited within 25 years. Other space agencies and organizations took similar actions over time. Yeah, okay.
Let's talk about how that. Let's go through how that exercise worked. And by the way, that requirement has gone to 5 years as of recently. It's no longer 25; it's now 5. So that's a little bit better. But I mentioned J.C. Liu, NASA. So he did a study that actually looked into this deorbit requirement. And who's managing this? Who's there with the clipboard going, Mark, your satellite is 25 years and 1 day old. You need to remove it. So 50% of the people, according to J.C. Liu from NASA, were following the 25-year deorbit. And as I said earlier, Liu's focus was to remove the big stuff to really make an impact.
So in the book, they moved towards active debris removal, ADR, as the solution to cleaning up LEO. And ADR, active debris removal, another catchy acronym from our friends in the space industry. The stumbling block isn't the technology, the stumbling block is who's going to pay, said Harvard astrophysicist Martin Elvis. Nice name. So who is going to pay?
I found a little interesting piece in here that I can believe this or not, Mark, will point back to Web3 and DAOs that'll tickle your fancy. So let's start with this guy, Coase, I think Coase. Ronald Coase, right? So he had this idea that, we can solve the tragedy of the commons.
1950s Nobel winning economist.
He did some good stuff. Nice. Thanks for clarifying that. I'm just calling this guy Coase and he's a Nobel Prize winner. Sorry to the family there. So essentially what he said, you can solve the tragedy of commons if you have few things figured out. If the costs of bargaining are low, if you have rational actors, and you can and property rights are clear. So guess what? A couple of these are really hard to figure out in space. So costs of bargaining. So costs in space, here's why it might be troublesome in space. The costs are high. Information costs are high in space. So collecting data on anything that's going on up there, right? Coordination costs are really high. So coordinating between the things up there and measuring that stuff. Enforcement costs are high. Who's enforcing all of these laws and regulations, right? And then, of course, currently we have no clear property distinction in lower Earth orbit. Specifically, GEO, I think you can carve out little slots. How do you feel about what Mr. Coase said? Nobel Prize winner Coase. Or Coase. Jeez. Terrible at these names.
I'm not really sure I understand the Coase theorem and how this applies to clearing up space.
Well, so if you have, I did a little comparison. So imagine you have like a factory and a fishery. Let's do 2 examples of this for the Coase comparison. So you have a factory that's polluting the water. You have a fishery that's losing its fish because of the pollution in the water. Okay. In this case, you have 2 parties. I'm the fishery, you're the factory. 2 parties just have to come together and be like, hey man, can we work something out? And I think what Coase is saying is the less people involved to coordinate that solution, the more likely it potentially is to happen. And on the converse of that, in space, you have countries, you have agencies, you have individual businesses, you have subscribers of the services that those businesses provide. And it's more complex going on in space than like a one-to-one issue on terrestrial.
Yeah, it sounds like a hypothetical economical solution that depends on well-defined property rights and low bargaining costs. So neither of which apply to space. So his
Next.
theory, I'm putting that to bed. Sorry to the family of Ronald Coase. I think that what this needs is the private sector. I think this needs real financial incentives to sort this mess out. It needs visionaries. It needs visionaries and private funding. It needs Astroscale.
Nobu Okada, the Napster moment for space. So inspired by, what was he inspired by?
He was inspired by Mamoru Mori. Sorry for the pronunciation. Japan's first astronaut. Mori, a national hero, gave Okada a handwritten note which read, "Space is a place where your generation shines." And then he forgot about it and went to business school. And a few, later on, having a midlife crisis, he decided to follow his passion, having made his fortune.
Let's talk about his approach to this. So he looked at it from, let's call it a conjunction. They call it a triangle in the book, I think, but technology, legal, and financial challenges addressing all of this stuff. We talked about the financial ones. There's not enough drive and need in the market to fund the endeavor, right? But what do? They use magnets. They use magnets on their satellite to basically lock in to old satellites and yank it down into the atmosphere and burn it away. They did a test to deorbit a satellite. I think the test worked, right?
No, the test crashed and burned. Astroscale adopted a three-pronged strategy to try to move the needle on space debris. 1, develop cost-effective ADR technologies. 2, create a business case for its technologies. And 3, inform and eventually help shape international policies around space debris. They settled on magnets, as you said, developing a satellite that can rendezvous, dock, and then safely remove a defunct satellite with magnets. And then it was 2017, 4 years into the Astroscale story, they were on a launch pad in Siberia, and
lost the
the
whole
launch
bit.
vehicle failed, and all the payload, including Astroscale's first satellite, were destroyed. 4 years of work gone in a flash. And so the same thing happened with SpaceX, didn't it? There's a lot of explosions in space. We've spoken about this with data centers. You can experiment in space, and they all did. And he went back to the drawing board. Within a year, the company had raised 100 million and was back on track. 4 years after that failure, so 2021, an Astroscale satellite approached a small companion satellite, stuck to it, and demonstrated that their magnet locking system works in space.
It's pretty cool. And I think I looked to see what they're doing lately, and I think, according to what I found, there was a ESA contract regarding, it's called in-orbit reuse and upgrade. So I think what they're looking at next is actually attaching to a satellite, doing some repairs, and letting it get back to work. So that is a contract that allegedly has been awarded to those guys. End-of-life services for satellites. End-of-life service. That seems like very like a funeral, like they're a funeral director or something, like where we're providing end-of-life services for satellites. We bring all the satellite's family in. We have a nice little talk. We tell what the satellite did for its life. Maybe told some jokes.
Keep them peaceful. Remind them of the good times, and slowly descend or ascend. Yeah, Astroscale. What's interesting, I think, is with Astroscale is so they create a solution, they get magnets, they go into space, take it out. I don't know how quickly they can do this and how quickly it works, but as we've learned, when Starship is launching every 2 minutes, there'll be plenty of time to take some of these Astroscale satellite magnets up into space. But it got people talking, it got governments talking, it got people aware of what the problem was, and
good on them.
Global norms, yeah.
Good on, trying to. There was a phrase in the book that was really cool. They want to make this stuff routine. So it's just like a wrecking service on the interstate, just like a tow service on the interstate. No one thinks of a tow truck. No one. But hey, if there weren't any tow trucks, the highways would be crowded. And I think it's a really cool way to look at it. Nobu, we are ready to have a chat with you. Would love to learn more. Sounds Super interesting.
Are you optimistic?
About what?
Space debris.
It's interesting. I mean, I think it's cool that people are like looking at a problem, and this guy's been working at it for 10 years. Like, this isn't like yesterday he was like, hey, let's put some magnets on a satellite and try to yank them out of the sky. And no, he's been at this for like 10 years, and he had to learn. He didn't know anything about it. And he just started interviewing experts and long journey. But he wanted to solve it. I think it's going to be a big issue with launch costs coming down. Everyone's throwing stuff up there. There's no coordination. What a license actually, I read this up too. What a license actually gives you is just permission to throw something up in a shared space. It's not, hey, you can operate at this particular degree of angle, this space. So I think it's going to get really complicated until someone emerges as the coordination mechanic. Hey, NASA, this could be you. What if that was
Do
you,
you remember
NASA?
last week? Well, remember last week we was talking about space stations and the incentives, the financial incentive to build space stations, and we were asking the question, what can you do in orbit better and more efficiently than you can on Earth? So business idea. I know we're going to launch a thinking on paper launch company, but now we could do an Astroscale competitor.
So we just like moved to orbit and a thinking on paper, junker that goes around and just picks stuff up and chucks it down. All right, I'll expect the business plan on my desk next week, Mr. Fielding. That's
why I didn't go to business school. Market power.
All right. So let's talk about this. A lot of this chapter talks about monopolies and what happens when monopolistic powers control segments of a market or a market in general. And enter SpaceX. Yeah, according to the book, the prices are starting to creep up a little bit, but they're innovating like mamma jammas, dude. So, I mean, how does that affect normal monopolistic theory?
Doesn't affect the theory. It is an example of the theory.
But it's talking about the risks of having a monopoly. And if you have a monopoly that continues to innovate and prices are only incrementally going up, I would argue that monopoly is probably still doing okay in the grand scheme of things as far as benefiting the market, at least at this time.
Keep going.
There's a market. There's a monopoly. Okay. Controlling the whole market. Everything in that market is 90% driven by that company. So one situation could be gets all the customers in the market and they're like, yo, shut down the R&D. Hey, marketing, let's crank up our costs by 2x. We already got this captive market. We don't have to iterate. We don't have to do anything. Let's just lock and load. And that benefits the monopoly company, like the monopoly, but it does not benefit the market and the people, the consumers buying the stuff, right? Because they're stuck with higher costs and shittier products over time, right? But scenario number two, you have a company that, maybe prices are going up a little. And according to the book, the prices aren't going up that dramatically, right? But you still have people innovating to make the product better, to take one product and take the next step on a larger mission to create a space economy, right? That's a big step. That's going to require a lot of little steps along the way. They're continuing to take those little steps along the way. And it's all under this mission-oriented versus profit-oriented. Although it said mission-oriented versus profit-oriented in the book, referring to SpaceX. But they're profit-oriented too. But yeah, he wants to go to Mars. First way to get to Mars, we got to figure out a way to lift stuff off the planet for cheap, do it over time, make it easier to get stuff up into orbit. And then we kind of take the next step, right? In that case, this monopoly is still benefiting the market in a way,
without doubt. Yeah. As they say in the book, without doubt, it's unarguable that the space industry is where it is because of SpaceX. And if you didn't have SpaceX, it wouldn't be anywhere near where it is. The thing with monopolies, listen to us talking about monopolies, maybe like a mature industry and an immature industry react differently to monopolies. And like you said, the visionary, like SpaceX, is built on a very, very, very strong mission statement to take civilization to Mars and beyond. And that's the driving force behind it. They say in the book that's like the driving Force every week. Elon's there reminding everybody that that is the mission of SpaceX, and everything else comes second to that mission. And he's nobody's fool. He knows that. He knows where SpaceX stand in the market. He knows the dominance that it has. It knows the importance that it has. He knows also that the industry is very, very immature, and it needs other actors in it, even if those actors, if their only role is to push him and to push SpaceX and to push the engineers on to bigger and better things. If he's using them as fuel, it still needs these other actors, at least in the short term. What happens in the long term is a different story, I think.
Couple quotes for you. NASA Administrator Jim Bridenstine: there is only one thing worse than a government monopoly, and that is a private monopoly that the government is dependent on. I do worry we have put all of our eggs into one basket, and it's the SpaceX basket. But what other basket what other basket is there right now? What other basket is there? There are a lot of companies that have kind of fallen away from a launch perspective, from a capsule build perspective, from a rover perspective.
A private monopoly that the government is dependent on. The war in Ukraine, the future, you heard it here first, war in Iran. Every American, probably every American submarine, every American aircraft carrier, every American government department in some way relies on a little bit, or if it doesn't now, it soon will be, of the SpaceX infrastructure, whether that's Starlink internet, whether that's rocket launch, whether that is taking whatever weapons they have, secret weapons, into space. Whatever they're doing, they are reliant on SpaceX. And the stronger those links become, the more history is built on those relationships. The stronger that bond becomes, the more powerful that monopoly becomes, the more worried Jim Bridenstine becomes.
Well, there's no question SpaceX has done tremendous things. No question. Where we are now, just if you just look at launch costs, where we are now is crazy, as where we were, a decade ago. But it's really a couple other quotes for consideration here. This one, I guess from an article in the New Yorker, I think. So, quote, Musk, a sometimes erratic businessman and private citizen with a penchant for conspiracy theories, has played a critical and even unprecedented role in an international conflict, shaping it in a way no mere tech baron could. There's little precedent for a civilians becoming the arbiter of war between nations in such a granular way, or for the degree of dependency that the U.S. now has on Musk. Interconnected, baby.
And that's 2 years ago.
Yeah.
But we are fortunate, Jeremy, that leading space companies have much more to gain by growing the pie and claiming their share of it than by slowing growth to grab a larger share. We do have that mission statement. Should we worry about SpaceX? And if so, what should we do about it? Do you worry about SpaceX?
It's such a weird thing, man. Like the control that someone might have with all of the satellites. And now recently, as this wasn't in the book, but this was over the past week, SpaceX has acquired XAI. A lot of people think it's in large part to make the numbers look a little bit better from an IPO perspective, but this is not financial advice, by the way. That makes a pretty big jump. So imagine one company firing the rockets, one company running the launches, one company with the largest constellation of, say, 1 million satellites that can surveil, that can communicate, that can turn on and off access to essential services to nearly anywhere in the world. That seems as we have the pendulum between doom and utopia. It's definitely, I don't know. I love that what they've done, hard work and like the engineering and the drive to do what they've done with rockets and launch and all the things they're getting into. Man, it's amazing. So I'm in a little middle ground with that I'm struggling to communicate well.
everyone says this, that the most important time that we all live in is the now and the here and the now. But what happens with Artemis and what happens with Starship over the next 12 to 24 months will shape what happens next. It will shape NASA and by extension the American government's role in the space industry. It will shape how much of a role SpaceX take on. And if, as we've been learning recently, he does get one Starship rolling out of the factory every day, and these launches become so regular, and SpaceX control all of that,